Okay, let us see chapter 2 part 2. Chapter 2 part 2 is actually the application, okay? What you have to know is we will apply anything that you learn, okay? You learn in chapter 1, chapter 2 part 1, okay? How to differentiate and so on. So we will apply here. Okay, let us see. Okay, this is the objective. So let us see what is application that we need to do. Okay, so first you have to know the increment. Okay, the increment. When we talk about increment, it means that let's say you want to increase something. Okay, you are designer, engineer or what, right? You want to increase some object. For example, right, you have object box. Okay, for example, you have the height of box is 2 cm. After that, you increase from 2 cm to 6 cm centimeter. So how much the difference between small one and the big one? So that's why we call increment and total differential. So we have two terms you have to know. First is actual increment. This one, okay? Actual increment, the formula is this. Okay, how to remember is when we talk about actual, means that this x, okay, you plus del x. 7 cm, you add 5 cm, right? So same thing. X plus del x. So 2 plus 5 cm, you will get 7 cm. Okay, like that. Okay, and then you also add for y. Let's say you you add for y also, right? You want to create a box, for example, and then you increase the length of x, increase the length of y. Okay, so you will get the formula is y plus del y. Okay, and then minus the old one, the original one. Original one is fxy. So this one is actually same like 7 minus 2. You will get 5, something like that. Okay, but that one is just one value, right? But how about if you have function of two variables? Okay, if you have function of two variables, you will do like this: x plus delta x plus comma y plus delta y. So you will know what is del z. Okay, you have 3D function of three variables. You have 3D, like you have this box, for example. Okay, this is box. And then you x, this is x, y, z. You add the length for x, okay? This one, you add, right? From small become big. And then y also. This is y, the length of y. And then you will know that what happened to del z. Okay, you will know that, oh, for del z, the increment for del z is like this, okay? Actually, the formula is come from the definition, okay? From differentiation definition. This one you already learned chapter 2 part 1. So I didn't explain again this one. Okay, so what you have to do from the definition, you will multiply this. And then for del y, you will multiply this. You see? That's why you get fx del x, fy del y. Okay, after that, what you have to do is you will add this one. Okay, fx plus delta xy. Okay, so you get this plus, okay, fxy plus delta y, this one, right? Okay, so means that you plus. If you plus both, okay, you will get del z. Okay, so del z is the increment. Like I said, if you add, you have box, you add 2 cm x axis, and then you add 2 cm y axis. Okay, then what happened to dz? So you will get the answer one. So you will get total differential. This one we call total differential. Okay, total differential for z is fx. Okay, fx del x, fy del y. Okay, so you have to remember this formula also. But actually, you no need to memorize how to get the formula. Okay, you no need to know, is it need to plus or what? No, you just need to remember this, the final one. After that, what I can say, okay, you have del x. Okay, del x is the differentiation, right? Okay, remember that. Okay, we use limit, right? Okay, limits means that approaches close to. Okay, so del x is close to 0. Okay, so and then del y close to 0, very, very small. Means that we did some changes, very, very small changes. Okay. Then you also can denote as dx. So you can use dx. Okay. Dx. Same. We can say that del x is, can do like this. Del z equal approaches to dz. This is means that same. Close to. Okay, so can use dz. If you want to use del z also can, both can. Okay, del z or dz. Okay, so from the definition, differentiation of definition, so you will get this formula. Okay, approximate. Okay, this one is approximate increment. Approximate increment means that you approximate. Okay, you remember you differentiate, right? Okay, you differentiate, then you will get the close one. You get limit, right? Limit something. So this one we call approximate. Okay, the first one, remember? The first one is actual. Actual increment. So remember two terms. First is actual increment. The second is approximate increment. Okay. So from approximate increment, we also can say that one is total differential. Same thing. See? Same thing. Total differential. Okay. So you will know that what is the total for dz, total differential. What is the changes for dz? Okay, this is formula. You will apply this in your maybe application, right? Okay, so if you have three independent variables, same thing. Okay, let's say you have del v. So del v is fx del x. Okay, so you plus fy del y. And then fz plus, times del z. So you can remember this. Okay, this one didn't give in an test or what exam, the formula. You have to remember. Okay, the total differential is dv. Okay, go to fx dx, fy dy, fz dz. Okay, let us see example. If you see example, we can understand. Okay, let's say given is f. Okay, f equal to 2x square plus y cube. Okay, then the question say xy changes from 0.12 and then 1.01, 1.9, 1.98. Okay, mean that let's say this is y, z, you have z here, z and then x and then y. Okay, and then you have 3D, any 3D, 2x square y plus y cube. Any shape. For example, you have 3D, I didn't sketch. Don't know how. Okay, any shape, right? Any 3D. And then the question said x. Okay, x from 1. Okay, this is 1 to 2. Okay. I think no need 3D this. Okay, wait. Okay, from 1 to, this is 1 and then 2. X, y. Okay, y is 2. This is 2 here, 2. Okay, let's say this point and then 1.01. Okay, let's say 1.01 is here. Okay, and then 1.98 here. Okay, so the point for xy change. Okay, let's say you have the shape and then you increase. This one we can say that you decrease. Wait, 1 point. Decrease the y, the length of y, and then you increase the length of x, right? Okay, understand? Then we want to know what happened to z. Okay, what happened to z? So you have shape and then you decrease the length of y, and then but you increase the length of x, and then you want to see what happened to z. So without you can use this formula. Let's say you have a company letter, right? And then you design some object, and then you ask your staff to increase the length of x, okay, and then decrease the length of y. And then you want to know what happened to z. Let's say you have box. And then you can use this formula, class. You can get, oh, actually the change of z is like this, the total differential. Okay, the first question is, find the approximate. Okay, approximate means that you have to differentiate. Okay, so remember the formula, dz equal to fx dx plus fy dy. Okay, so what is fx? You can differentiate as usual. Fx 2x square y plus y cube. Okay, this one. 2x square y plus y cube. So fx is 4x. Okay, 4xy. 4xy. Alright, so, and then how about fy? So differentiate f with respect to y, you get 2x square plus 3y square. Okay, so you get this. And then what about dx and dy? Okay, dx is the changes that you did. Okay, let's say 2 cm to 7 cm. So 7 minus 2 is 5 cm. Like that. So remember the second point is 0.01. The first one is 1. So 1.01 minus 1, you get 0.01. Okay, and then y. Y is 1.98, okay, minus 2. So you get negative 0.02. Okay, I said that you increase the length of x, you reduce the length of y. That's why you get negative. Okay, and then what you have to do is substitute into this formula. See, you get this. Okay, so fx is 4xy, and then dx. Fy is 2x squared plus 3y squared, and then dy. Okay, so for xy, you have to substitute the original one. Okay, 1. The first one is 1. Okay, y is 2. And then dx. Okay, and then plus 2x. Okay, remember this is 1. Okay, and then y squared, 2. Okay, so you multiply with dy, negative 0.02. Then you get negative 0.2. The total differential for that function, okay, is negative 0.20. Okay, next we look at example 1b. Okay, 1b, the question asks to find the actual change in z. Okay, if we talk about the actual, no need to differentiate because this one is actual. What you have to do is you put the value. Okay, so you see, the original one is fxy. Okay, 2x squared y plus y cube. And then we want to know what is the actual increment. So what you have to do is x, you plus del x, and then y, you plus del y. Okay, so this is second function, right? Okay, and then you minus the old one. Okay, the first one. So what you get? F 1.01 and then comma 1.98. Okay, this one you increase already for x, and then this one you decrease already for y. You reduce the length, right? Okay, and then you minus the original one, the first one, 1, 2. So you see, you substitute the value. You substitute the value here. Okay, 2x squared y times y cube, right? Okay, so you substitute all values, you will get negative 0.1980. So this is actual increment. Okay, approximate one is negative 20, right? So actually close to negative 0.2. Negative 0.1980 is close to negative 0.2. So you see, what we can conclude is by using the differentiation, we can get the total differential. We can get the increment. We can know what is the increment. Alright. So it's also what I can say. This is why we learn differential. Why we learn the differentiation. Okay. So you see, same, right? Negative 0.2, negative 0.19. 80. Okay.